Hello students, welcome back to Future Foundation. Students, in this video of vectors and three-dimensional geometry, we will discuss line of intersection of two planes. So let's start. So write down the heading, line of intersection of two planes. In this we will write, consider two planes P1 and P2 as shown in figure. So students, these are two planes P1 and P2, and the line of intersection for plane P1 and P2 be this yellow line, right? This is line of intersection. Now we are interested in finding the equation of this line. Okay, so now for this, okay students, so we can see if this is normal vector n1 for plane P1 and this is normal vector for plane P2, that is n2. So this line will be along the vector n1 cross n2, right? As we know, line is lying on both planes and n1 vector and n2 vector are perpendicular to n1 cross n2. So line will lie along n1 cross n2. Okay. Now we are interested in finding the equation of line of intersection, which is given in n-symmetrical form. That is, if P1 is E1x plus P1y plus C1z is equal to D1 and P2 is E2x plus P2y plus C2z is equal to D2, then equation of line in unsymmetrical form is E1x plus P1y plus C1z minus D1 is equal to 0 is equal to E2x plus P2y plus C2z minus D2. Okay, so this is nothing but equation of line in unsymmetrical form. So how we can find equation in symmetrical form? So for this, right, some steps for finding line of intersection in symmetrical form. Okay, so step 1 is put z is equal to lambda in both planes or equation of planes, right? As we know, equation of line contains infinite points, so we can put z is equal to lambda for any real, right? Now second step, obtain two equations after putting z as lambda in both equation of planes, right? Two equations in x and y, and then solve in terms of lambda, right? So now we have x, y and z in terms of lambda. So we have the equation line, right? Uh, let us consider an example. Let us take an example. Question is, reduce the equation of line x minus y plus 2z is equal to 5 and 3x plus y plus z is equal to 6 in symmetrical form. Okay, so for this we will put z is equal to lambda, right? If I put z is equal to lambda in both planes, then x minus y plus 2 lambda is equal to 5 gives you x minus y is equal to 5 minus 2 lambda, right? and from second equation we will have 3x plus y plus lambda is equal to 6 implies 3x plus y is equal to 6 minus lambda. Now if I add both these equations, I will have 4x is equal to 11 minus 3 lambda. Okay, or 4x minus 11 upon minus 3 is equal to lambda, right? Now if I put value of x in any one of these two equations, I will get y in terms of lambda. So also y is equal to 6 minus lambda minus 3x. X is 11 minus 3 lambda by 4. So 24 minus 4 lambda minus 33 plus 9 lambda by 4 is equal to y, or y is equal to minus 9 plus 5 lambda by 4, or lambda is equal to 4y plus 9 upon 5. Okay, so now we can compare lambda for x, y and z. So therefore equation of line, which is 4x minus 11 upon minus 3 is equal to 4y plus 9 upon 5 is equal to z minus 0 upon 1, which is equation of line in symmetrical form, right? So students, let's meet in next video. Till then, bye bye, take care.